Good morning children. In today's class we are learning reduction formula. When the power is more, how can we reduce to lower powers? Especially sin power nx is coming in the integral with a limit 0 to pi by 2. I can rewrite it as n minus 1 by n I n minus 2 whenever n is more than or equal to 2. The same idea I can use for cos also. Especially this I keep on applying. We reduce the formula as integral 0 to pi by 2, whether it is sin power nx or cos power nx dx. We have n minus 1 by n. Keep on reducing to 2. n minus 3, n minus 5, like that in the numerator. Denominator, n minus 2, n minus 4, and so on. If n is even number, we will stop with 1 by 2. Whenever n is even, include pi by 2 also. If n is odd, we will stop with 2 by 3. And so we will write 2 by 3 into 1. So if it is even, I write pi by 2 extra. If it is odd, I just write into 1. Even numbers stop with 1 by 2. Odd numbers stop with 2 by 3. Now when we see exercise, we will know how this is very easy to remember. It is a very useful formula in higher powers of sine. Now, suppose I have sine and cos in combination. Sine power m and cos power n. The same idea I can extend. This is one method to remember directly. What about m and n? We have a variety of steps to remember for that. First case, m is odd and n is even. We applying m minus 1, m minus 3, m minus 5 and so on. Denominator, we add the two powers m plus n, reduce 2 to 2. Till we get 2 by n plus 3 and the last term is 1 by n plus 1. If n is odd and m is any positive integer, we have this format. Denominator in all the patterns, it is m plus n, keep reducing to 2. But when n is odd and m is any positive integer, I stop with 2 by m plus 3. When m is odd and n is even, I stop with 2 by n plus 3 into 1 by n plus 1. If both are even, we stop with 1 by m plus 2, keep on reducing with m, where m is the power of sine, till I get 1 by 2, and as before in sine and cos, whenever both are even, multiply by pi by 2. Those who are able to remember, learn the formula and apply it directly. If learning the formula is difficult, we have the detailed method of working too, by simply remembering this formula. In a particular question, sine square is coming. I can rewrite as 1 minus cos square. Cos square is coming. I can rewrite as 1 minus sine square. So instead of this combination, we can remember only this formula, which is very simple to remember, and we can apply in detailed method instead of the 3 formula also. Let us see the exercise problems. Exercise 9.6, question number 1, subdivision 1. Evaluate the following integrals. Integral 0 to pi by 2 sine power 10x dx. Let me recall the formula. Integral 0 to pi by 2 sine power nx dx is n minus 1 by n, n minus 3 by n minus 2. Keep on reducing 2 in the numerator, 2 in the denominator, till I get 1 by 2. because n is even in this case. Once I obtain 1 by 2, remember to put pi by 2 whenever n is even. Here n is equal to 10. How do I substitute 10 minus 1 by 10, 10 minus 3 by 10 minus 2, 10 minus 5 by 10 minus 4 and so on. So here I put and so on, but here I must subtract. So 10 minus 1, 10 minus 3, 10 minus 5, 10 minus 7, 10 minus 9 gives me 1. So stop with that. Denominator 10, 10 minus 2, 10 minus 4, 10 minus 6, 10 minus 8 gives me 2. Once I obtain 1 by 2, stop with that and remember to put pi by 2. As we simplify, 9 by 10, 7 by 8, 5 by 6, 3 by 4, 1 by 2 into pi by 2. See, anything I can cancel. 5 cancels 2 times. 3 cancels 2 times. 9 into 7, 63 into pi by. Denominator 2 into 2 into 4 into 2 into 8 into 2 gives me 512. Second question. Cos power 7x. Now it is odd. So I recall the same formula, but odd number tells me stop with 2 by 3 into 1. Here n is 7. When I substitute n is 7, 7 minus 1, 7 minus 3, 7 minus 5. 7 minus 5 gives me 2. Stop with that. Denominator 7, 7 minus 2, 7 minus 4 gives me 3. Stop with that. Into 1. As we simplify, it is 6 by 7, 4 by 5, 2 by 3 into 1. Cancelling and we multiply, we get 16 by 35 and that is the answer. Third subdivision, sin power 6 2x. Sin power 6 x can come to apply the reduction formula. If any other term comes, let us substitute. Put 2x equal to t, differentiate, t becomes dt. 2 into x becomes dx. As we change the limits, x is from 0 to pi by 4. When x is 0, t is equal to 2 into 0, that is 0. When x is pi by 4, t is 2 into pi by 4, that is pi by 2. Now the limits are 0 to pi by 2, sin power 6, 2x becomes t. Dx is dt by 2. Bring by 2 out. It is sin power 60 dt. I can very well apply integral 0 to pi by 2 sin power nx dx formula. Here 6 is even. I will stop with 1 by 2 into pi by 2. So let us start. 6 is the number. 6 minus 1, 6 minus 3, 6 minus 5. Stop with that. Denominator 6, 6 minus 2, 6 minus 4. Once I get 1 by 2, remember to write pi by 2 whenever n is even. As we simplify, it is 5 by 6, 3 by 4, 1 by 2 into pi by 2. We can cancel 3 with 6 as 2 times. So my answer is 5 pi by 4, 16 into 4, 64. Fourth subdivision, integral 0 to pi by 6 sin power 5, 3x dx. Again, 3x mustn't come. Put 3x as a substitution. Whenever I substitute as t, differentiate, t becomes dt. 3 into x becomes dx. Changing the limits, 0 to pi by 6 is x limit. T. When x is 0, t will be 3 into 0, 0. When x is pi by 6, t will be 3 into pi by 6, that is pi by 2. We can change the limits and write 0 to pi by 2. Sin power 5. 3x is t. dx will be dt by 3. Bring by 3 out. Now it is 0 to pi by 2 integral sine power 5 t dt. Whenever the limits are 0 to pi by 2 and it is sine power of some variable, I can apply reduction formula. Here n is 5, which is odd. So stop with 2 by 3. Start from 5, it is 5 minus 1, 5 minus 3, that itself gives me 2. Denominator 5, 5 minus 2. Once I get 2 by 3, stop with that and put 1. As we multiply, it is 8 by 3 3s are 9, 5s are 45. So 8 by 45 is my answer. Fifth subdivision, integral 0 to pi by 2 sine square x cos power 4 dx. You can directly apply reduction formula or else. Sine square can be written as 1 minus cos square x. Multiply. Cos power 4 into 1 is cos power 4x. Cos power 4 into cos square is cos power 6x. Now, this is cos power 4, that is I4. This is cos power 6, that is I6. Here n is equal to 4, here n is equal to 6. Just apply the even number formula. It is n minus 1 by n minus 3 by n minus 2 and so on up to half. Whenever half comes, we have to put pi by 2. Wherever n is coming, I start from 4. 4 minus 1, 4 minus 3 by 4 into 4 minus 2, pi by 2. Same way apply for 6. As we simplify, let us take LCM. It is 3 pi by 16 minus 5 pi by 32. Taking LCM, we get the answer pi by 32. So, whenever you have a combination of sine and cos, we can very well change one function as another. So, sine square we have written as 1 minus cos square. Multiplying, we arrive at two different integrals. Cos power 4 separately, cos power 6 separately. Apply the formula for 4 as well as 6. Take LCM and simplify to get pi by 32. Sixth subdivision, evaluate integral 0 to 2 pi sine power 7 x by 4. X by 4 must not come. So make it as a substitution. So t is equal to x by 4. Whenever we substitute, we differentiate. T becomes dt. X becomes dx by 4 as it is. So what is dx from here? 4 dt. As I change the limits, when x is 0, t is equal to 0 by 4, that is 0. When x is 2 pi, t is equal to 2 pi by 4, that is pi by 2. So now the integral becomes 0 to pi by 2 sine power 7 x by 4 is t. dx is 4 dt. Bring 4 out. It is integral 0 to pi by 2 sine power 7 dt. Odd power. Apply the formula. Simplify and get the answer as 64 by 35. Seventh subdivision, evaluate integral 0 to pi by 2 sine power 3 theta into cos power 5 theta d theta. Sine power 3, let me split as sine square theta into sine theta. Sine square can be written as 1 minus cos square theta. Sine theta we shall combine with d theta. Go with the substitution. Cos power 5 is coming. So t is equal to cos theta. When I differentiate, t becomes dt. Cos theta becomes minus sine theta d theta. Changing the limits, theta is from 0 to pi by 2. Here I have changed as t. When theta is 0, cos 0 is 1. When theta is pi by 2, cos pi by 2 is 0. Substituting back in the question, 0 to pi by 2 will now become 1 to 0. Integral. Cos power 5 theta is t power 5. Sine square, which I have written 1 minus cos square, I can write 1 minus t square. Sine theta d theta, I can write minus dt. As I have minus symbol, I can interchange the limits. 1 to 0 with a minus symbol, I can write 0 to 1. T power 5 into 1 minus t square, let us multiply. T power 5 into 1, t power 5 minus t power 5 into t power 2, add the powers, that is 7. Just integrate. T power 5, remember the formula, x power n dx becomes x power n plus 1 by n plus 1. So t power 5 will become t power 6 by 6, t power 7 will become t power 8 by 8. Put upper limit minus lower limit. Take LCM and simplify. We get 1 by 24. This is first method without using the reduction formula. Second method. Let us recall the reduction formula. Sin power mx cos power nx dx. Denominator m plus n keep reducing to 2. When m is 3 and n is 5, both are odd. We start from n minus 1. Here n is 5. So 5 minus 1, 5 minus 3. The moment I get this, I start from 2 by m plus 3, 1 by m plus 1. So here already I am getting 2 by m plus 3. What is m actually? M is 3. 3 plus 3 is 6. Here I have attained that answer. So immediately the next number is 1 by m plus 1. 1 by m is 3 plus 1. So as we keep on doing, we must remember when I attain this 2 by m plus 3. Once I get this 2 by m plus 3, as I keep on reducing, stop with that and write 1 by m plus 1. So 1 by m is 3 plus 1. As I multiply, I get the same answer. But remembering the formula is difficult. We can very well do it with a substitution method. Eighth subdivision, integral 0 to 1 x square into 1 minus x the whole cube dx. Whenever the limits are 0 to 1, if it is of the pattern x power some number, 1 minus x power some number, I can very well use this formula, m factorial this number, n factorial this number divided by together m plus n plus 1 factorial. Just easy to remember the formula whenever it is of the limit 0 to 1. X power some number, 1 minus x power some number. Treat the numbers as m and n. The formula is m factorial, n factorial by m plus n plus 1 factorial. Here m is 2, n is 3. So 2 factorial, 3 factorial by 2 plus 3 plus 1 factorial. 2 factorial is 1 into 2. 3 factorial is 1 into 2 into 3. M plus n plus 1, that is 6 factorial, which is 1 to 6. Cancelling and simplifying, we arrive at 1 by 16.